So I'm Ella Gilbert, I'm a climate scientist working at the British Antarctic Survey. I'm really interested in the atmosphere and climate change particularly. I'm also really keen on clouds. So I'm here to talk a little bit about what clouds mean, how we can use them to read the weather, and what we can do looking every day in our skies to predict what's to come in the forecast. I really love clouds, as you can probably tell, and they're really amazing. They're so complex, and we actually don't know that much about clouds. And I mean, how long have humans been staring up at the sky? So I thought I'd give you a brief overview of cloud stuff. Either you have stratus, which means layer in Latin, like I said. You've then got cumulus, which means heap, so that's when you get them piled up. And then cirrus is the last one. So they're the wispy, feathery ones. And all the clouds that you see would be a combination of those. All of them have different kind of properties, they're formed by different processes. But generally speaking, there's two main ingredients for a cloud. One is cooling, so the water vapour gets cool enough to turn into either liquid water or ice. And the other one is some kind of like uplift, and you've got to make it vertical. Cumulus are these kind of heap clouds, and they're quite tall vertically, aren't they? So the reason they're like that is because they're formed by convection, which is what happens when you have the sun heating the ground gets nice and warm, the air above it gets nice and warm. As I'm sure you know, warm air rises, so you get this circle effect going on, and that extends to the clouds. So once it hits a certain point, that rising warm air will cool down because it's going up in the atmosphere. Once it gets to a certain threshold, it will condense and it will turn into a cloud. But because the air is still rising and falling in kind of a circular motion, that's how you get that vertical height of the cloud. So that's caused by heating, essentially. And then if that happens loads and loads and loads, you get your cumulonimbus, which is your thunderstorm clouds. A cloud is darker. The reason it goes dark is because it has more water in it, and water is less, the bigger the droplet is, the less reflective it is. So we see it as darker colours because it starts absorbing more radiation, and the white is when you've got lots of little tiny droplets that are not going to fall on you as rain. So stratus is when you get like basically a sheet, and it's homogeneous. You can't really distinguish distance because it's just like one colour, really flat, thin layer. Obviously you can't see through it, but usually they're very thin. They're mostly made of water rather than all sorts of different stuff, and not so much ice. Typically you get them, either they don't rain at all or they're drizzly, really like it's fine misty rain. Sometimes you get other types of rain through stratus clouds, but that's usually because there's a sneaky other cloud hiding above it. So it's hard to tell because obviously you can't see above it. If you're on a plane, of course, you could see. And then the final one is cirrus clouds, so they're those wispy ones really high up, and those are mostly made of ice. They all look so wispy because at that height in the atmosphere, when an ice crystal, they're made of ice crystals basically, so when the conditions are right, it's quite moist up there, and these ice crystals, if they leave the cloud, they don't instantly evaporate. So whereas with a cumulus cloud, the water droplet would leave the cloud and it would go pss, and instantly evaporate into thin air. Whereas up at that level, the ice crystal would leave the cloud and it would take a long time to evaporate. So that means it has much like fluffier edges and it's much less defined. So contrails, sometimes you'll see loads of them, and sometimes contrails turn into cirrus as well, because the plane will go across the sky and it will emit its water vapour at that height, and sometimes it will just stay there forever. I mean, I'm sure you've seen days where there's just these lines, streaks across the sky, and no planes in sight necessarily. They're just still there. And the conditions have to be perfect for that. Today, it looks a bit like a shooting star, that contrail over there, sort of disappearing after a little while. So it's obviously dry enough at the height that plane is flying at for all the water and ice in the cloud to just fizzle away into nothing.